RNA. This is, there's an enzyme called RNase, which hydrolyzes RNA. We're seeing the smallest possible chunk of RNA, a little dinucleotide pair here. One base linked to the next one with normal linkage, a phosphodiester linkage. The enzyme ribonuclease can take this little dinucleotide substrate and chop it into two. That's what RNase does. It chops up RNA molecules. It can attack that perfectly well. If you present the enzyme with this guy, though, look at it, it's entirely identical except for this highlighted O in the phosphodiester linkage. In this inhibitor molecule, it's been replaced by a CH2. So it's not really a phosphodiester. It kind of looks like a chunk of RNA, but it's got this crucial difference. The RNase molecule, the enzyme would normally attack right there. It goes to attack here. There's no oxygen to react with chemically. You can't do the chemistry to break that apart. But this looks so much like the natural molecule that the inhibitor can fit right in there. It's a structural analog, a close lookalike. So it sneaks into that active site, and it's probably binding, of course, to these alcohols and amino groups.
Okay, so that's where
it's
'cause
docking.
it can't bind at the other.
Yeah, this is where it attacks, but the active site would be binding all the way around here. So it looks like 99% like the natural substrate. It gets fooled, it stocks at that site.
And that's where it would be binding on the other one too. It would
Yeah.
just cut it beyond the binding.
The enzyme would wrap around this, and then some functional group of the enzyme, maybe a cofactor, maybe the enzyme
So that's
itself.
not the actual attraction.
No, the attraction is through all this other stuff. Remember, multi-point attachment is what gives specificity. So it's got probably some site that binds, makes a hydrogen bond there, or here, or has an ion pair with this guy. And the inhibitor can make all the same multiple attachments. So this probably binds just as tightly as that. But once it's in there, nothing can happen. So lots of drugs are this kind of thing. They are structural analogs of a normal enzyme substrate. So if you want a drug to stop a particular process in your body, just block an enzyme reaction, this would be one way to do it. Just design a molecule that's a structural analog with a natural substrate.